ただいまより六本木ヒルズ10
Thank you for waiting, ladies and gentlemen. I'd like to begin this program, Leading Edge Technologies and the Future of Society. Part of the Design the Future for Global Cities and Lifestyle Conference. This conference is being organized by Mori Memorial Foundation, Mori Art Museum, Academy Hills. And we're going to focus on leading edge technologies and culture, creative, and urban policies. And we have invited opinion leaders on these areas from throughout the world. We'll be spending the next 2 hours focusing on this theme, leading edge technologies and future of society. We'll have a glimpse of our life in 20 years' time, how technology will have evolved by that time. And I'd like to introduce our speakers for the session. Ms. Professor Elizabeth Diller is a founding principal, Diller, Scofidio, and Renfro. Her outfit and the studio integrating architecture and visual art and performance arts. She is currently a professor of architecture at Princeton University. Fiorenzo Omenetto is our next speaker, professor at the Department of Biomedical Engineering at Tufts University. His area of expertise includes photonics, photonic crystals, and photonic crystal fibers, nanostructural materials, nanofabrication, biopolymer-based photonics, and electronics. He is a fellow of the American Optical Society. Professor Sebastian Seung is with the MIT's Computational Neuroscience, Brain and Cognitive Science Department, the Media Laboratory, as well as MIT. He works on the connectivity pattern unique to brain neurons, and to analyze the brain big data, he is developing a methodology to connect human intelligence with machinery. And as moderator of this session, we have invited Dr. Joichi Ito of MIT Media Laboratory, and I'd like to call upon Dr. Ito now to the stage. He heads the MIT Media Laboratory, and also he's an outside director for Sony Corporation, and he's on the board of many organizations and business corporations. In 2008, he was chosen as one of the 25 most influential individuals on the net by Business Week, and in 2011, Foreign Policy chose him as one of the 100 philosophers of the world. So let us celebrate 10th year of the Mori building with discussion on designing the future for global cities and lifestyles. So good afternoon to you. Prior to this session, there was an opening session of the forum, and I see Director Nanjo of Mori Art Museum says technology is only a part of art. And there was a question, which do you think is more important, art or technology? It's one of the difficult questions to answer. And here we're going to talk about the leading edge technologies. I'm not fully comfortable with this because when you talk about technology, I always think that it has to be part of the art scene. Technology is a piece and parcel of art. But in Japan, we tend to make a distinction between arts and engineering. If you go to school, you have to make that choice, liberal arts or engineering. And in industry, one has to focus on areas of expertise in a corporate environment or in academic environment. So it's a vertically compartmentalized world of a specialty. It's a good structure to scale up your expertise. It's a controllable sort of a structure. But another thing that we discussed in the previous session is that whether in urban development, design should be rigorously controlled, or should it be a natural evolution kind of a process. In today's world, there are technologies that allow things to change very fast, and the systems that we have are very complex. So however well you may plan, the best laid plans are usually will turn out to be wrong. By the time the plans are made, things are moving on to the next stage. So the cost of preparing for the plan would turn out to be too expensive. I have a proposal that we make with the venture company, asking for 60 million yen in budget. But they spend 300 million yen whether or not to do this feasibility study. So feasibility study turned out to be more costly than the project itself. If it costs so much to find the feasibility, then why not just go ahead and do it? Previously, the Japanese tendency has been to be very visually controlled, always well concentrated in whatever he or she does do. But that could be a negative because what you need is a serendipity, luck. You have to be lucky. What this means that there are things that surround you. They could be opportunities or a chance. If you are concentrating on your driving skills, you don't see what's happening around you. So you have to widen your scope of view while not crashing your car into something. So arts, design, engineering, everything is there to inspire you. They're there. You have to make sure that you are incorporated into your life and your activity. So serenity and peripheral vision is all important. But today, as I said, our society is vertically compartmentalized so that there's no connectivity between them. In the complex world, the system based on planning, based on choices, is crumbling because things are happening all beyond our expectations. Unexpected things, surprise, will always be there, so that that requires us to be always flexible. So the best laid plans will always turn out to be wrong, and we have to be able to be flexible to react to the suddenly happening changes. So you may have degrees from school, but because of the degrees, you are compartmentalized. So please listen to your presentation today and think about your situation in Japan or the countries where you're from. And there's a thought that goes through in the mind of individuals, and also the thought process that is had by the organizations. And they have to be combined so that serendipity can be utilized. Now, Phil, well, earlier in the morning, there was a presentation. He works with the Nelly Oxman. So I'd like to invite him for his first presentation.
And I'd like to, it's very exciting to be here. I'd like to thank the organizers for inviting me. This is truly a delight. I'm a material scientist, so participating in a forum like this is a little bit foreign to me. And the first thing that I tried to do, at least to place this in context, was to look at the title of the conference, and so sort of imagine what I think that the innovative designing life and future could mean from my perspective. And innovative is something that we do every day, for sure in the lab. It's either by trying to find something new, or certainly what we do in our case is to reinvent something that has been around for a long time. The designing life part is very broad. And I think from a scientific standpoint, there are some very pragmatic aspects of designing life at its core, which can involve involve things like synthetic biology or tissue engineering, things that you implant that I will talk about, and possibly the way that you design sustainable resources or use sustainable resources. Whereas certainly life can be the design of life can be interpreted, I think, and you know this better than me, in distributed services and in global society and in social interfaces. The future to me, because of this material bias that I have, it might be more connected, whether it's on a human-human level or whether it's the human and the object. And the human and the objects are becoming much more connected right now. And you know, you can see it possibly in your everyday life, where you talk, your cars, your phones are becoming much more part of you. So the challenge is, are we going to be able to think about materials that are going to affect the way that you connect with fixtures or homes and buildings or larger infrastructure? So materials today, the status quo is that materials today for the most part are immutable, and they are very stable in their behavior, and they are disconnected from living matter for the most part, and they use a lot of non-renewable resources. And generally, the form of the material determines the function of the material itself. And materials tomorrow, I think, are going to be materials that are self-healing, that repair themselves, that transform themselves, that are very sensory, that disappear harmlessly, and maybe that are sustainable. But we cannot sacrifice the technological performance that we're used to. So we want to keep them at that level. And perhaps the form of the object will not reflect its function. And so the segue for me is, I've had this collaboration. I've worked with Silk for some time. I've had this beautiful collaboration with Neri, and I want to tell you a little bit about Silk. Silk is a material that we love very much, and how we think that this is a 5,000-year-old innovation in a certain sense. And you've seen the pictures, the images of a Bombyx mori silkworm. Here it is again. And so the message here is trying now not looking at the swarm as an additive building environment, but focusing on the silkworm as a chemical factory and as a material generator, and as a generator of a very powerful material that is polymorphic. So from the same starting point, a material that can do many, many things. And our process of transformation is that we go back. So we take the cocoons that we unraveled on stage today, and we boil them, and we melt the fibers. So we remove the sericin that was the glue that was talked about this morning, and we get a liquid silk solution, just like the solution that is in the glands of the silkworm. And then we use this solution as the starting point for multiple forms of silk. And the multiple forms that we have are very vast. So micro and nanoparticles, sponges, films, coatings, blocks, and ropes, and so forth. And I want to just go through an image gallery of these forms because I think it's instructive. So this is, for example, a 100% silk moldable plastic sheet, so to speak. Plastic, obviously in quotes. You can do these things. Photonic elements. My background is in photonics, you know, and so this is a credit card that is made 100% out of silk, and that you can store information in. So you can read it out optically, like you would a DVD, in fact. So you can write in various languages, digital optics. So this comes from the fidelity of being able to reshape the material on the nanoscale. You can do holograms. So this is a very large, it's a 12 by 10 centimeter image that is written on a film of protein. You can mold the protein so that it assumes a microneedle format. You can do what the worm does and take that solution and repull and redraw a fiber. And in this case, we want to make optical fibers to guide light. Then you can do blocks. So you can do, for example, gears and nuts and bolts and solid mechanical components. So these are all, again, 100% fibroin. They can be molded in tubes, such as this that we use for vein replacements, or in larger molded parts, such as bones. Or we do experiments where you actually try to make functional structures, like, for example, a maple seed. And you see here, this is from a museum exhibit that was curated by Thomas Duggan, and that's what you see on the right is the image of the silk maple seed flying. Cups. And then we can also, because of the technical aspects of silk and of the quality of the material, we can interface metals to it. So in this case, we can build sensors or formats of electronics that are unusual, implantable, flexible, and that can be interfaced with light. So these are many forms that are becoming progressively much larger. At this point, we can make rolls of film, much like plastic. The question is, why would you want to do these things with silk? And so I think the function comes in, and the function of this material is what is the real differentiator from conventional materials that you have today. All of the processes that you've seen before to make these materials are water-based. So the process is quite sustainable. The material is edible. It's implantable. The technological part, I say it's technological because we can do these things with optics and electronics. And another important aspect is that it preserves the biological function of materials, of the dopants that you mix. And so when you have all these forms and you mix them with all of these functionalities, what you get is very unusual material outcomes. And it's a particularly interesting connectivity between the biotic and the biological, the natural world, and the inorganic world and the materials world. So the so-called biotic, abiotic interface. So these materials that become it's a true playground for the material scientist, because you can start thinking of how to put things together and how to make unexpected materials, a form that behaves in a way that you didn't imagine before. And I think that the two themes are embedded materials, so materials that can be embedded environmentally and be resorbed in the environment, or biologically embedded, or just materials that you can use every day. I want to stress some of these augmented functions just to see, because I think that they are important and they do have some societal impact. One of the probably most impressive augmented function pieces is that if you mix biological matter into this liquid silk solution that you have, and it's simply like mixing a drink, then when you have your doped solution, then you can go back and go into all of these forms that I've described before. Whatever is mixed in is stabilized. So you have a very nice way of maintaining the activity of these biological dopants. And so what we did is, for example, we looked at stabilization of vaccines. And the first experiment was storing penicillin, liquid penicillin, that becomes inactive at room temperature in 2 days, whereas we made films with liquid penicillin that stabilized penicillin for 2 months at 60 degrees Celsius. So then we looked at measles, mumps, and rubella vaccines, and these are this is a very important societal impact if you think from two aspects. One is that you can break the cold chain, and there are many kids that need global access to vaccines. And the second thing is that also you improve your logistics, because you don't necessarily need the vial that we show here. You actually can store vaccines in films, and it becomes much more convenient to transport if you solve some of these issues. Other augmented technologies, you can add life to ordinary technology that we have in our desktop. So we can, with the same principle of stabilization, we can generate a bunch of functional inks. And the functional inks are, for example, things that enable you to do things like this, where you can print therapies. So this is the printed logo of a university close to MIT. Here we are printing antibiotics. Silk stabilizes an antibiotic. The antibiotics are released on a bacterial. The bacteria is killed according to the pattern that you print. At the same time, you can stabilize a lot of chemistries on paper, and you can turn paper into a multidimensional biological sensor. And you see an image here of these inks with an enzyme that turns color. And this was very interesting. We did it. We did this reasonably recently, and we had this concept of sensing paints that we looked at in the past with Emily Joko, who's an architect from New York as her master's student program. She was imagining a bridge that would monitor pollution through these sensing elements, through sensing paint that was distributed on the walls of the bridge, and that could emanate through scattering the status of particulates or the status of pollution that was present in the atmosphere. And so right now we are looking at actually this gas sensing through paintable and printable silks. The other things that you can do is you can look at human interfaces. How do we become more integrated and more communicative? And so we look at the features of, for example, conformality of silk. You can control the way that the material bends depending on the way that the proteins bind together, and so you can go from a rigid state to a very supple state where you adjust the mechanical properties, which means that you can interface with I apologize for the image, but you can interface with very low mechanical modulus surfaces like the surface of the brain, and this is a sensor, this is an interface that actually detects EEG signals in vivo from the surface of the brain, being able to follow the curves of biological tissue. And you can start thinking also of having more communicators. So the thing that you can do is you can become a transmitter and a sensor at the same time by integrating these materials, for example, on your teeth or on your skin, which are some of the things that we do. Other examples of where you fall in, not only on the surface, but you become biologically embedded, is, for example, use the fact that the material is edible. And so in this case, you see gold leaf garnish on a chocolate cake. Instead of having these sheets of gold, you can shape the gold like an antenna. And what you see here is this. You see this little antenna that is put on the surface of a slice of cheese, and this is the signal that you detect for all intents and purposes with a cell phone. And so it tells you whether there's bacterial buildup on the cheese and whether the cheese is fresh or contaminated, and you could eat it with the cheese if you so desire. So this brings in how you affect logistics chain, how you do smart packaging, and how you do sensors for health monitoring and food safety, which are very, very important for the future. This is an image of part of 100,000 antennas on the surface of an egg. And then lastly, I think we want to figure out how we control materials so that they disappear. We are challenging also the paradigm of electronics. And instead of having, the design rules that are typical of microfabrication and of silicon circuit design, we want to make electronics that dissolve on command. And the reason that we want this is twofold. One, therapeutic, and the second one is environmental. You can imagine that there's a lot of electronic waste that we could mitigate by exploring this type of approach. So what you see here is you see this little small chip that you see here on the finger is a wireless heater. And it's a wireless heater that is made of silk and magnesium. Magnesium is a salt that you find in your body. Silk is a beautiful material. And what happens here is that this heater gets implanted under the skin. And then you close up, and then wirelessly it gets powered on, it heats up, and it kills bacterial infection. So if you have surgery, you can put this patch in, you can control the progression of your infection, you can mitigate it, and then the chip melts away when you don't need to retrieve it. And you can do wireless lights as well. So my conclusion is that I'd like to think of these ideas that this can be scaled up and that the future could actually have an embedded component to it, where you do have a transition to living materials, where the materials become tunable mechanically and functionally, so that there is a transition between a heartbeat and between the human and the buildings and the object that surround him. Thank you.
Thank you, Theo. And next we'll have Sebastian come up and talk. That was it.
Well, hello, everyone. I'd like to thank the Mori Foundation for having this wonderful meeting. And I'd like to say that Tokyo is already one of my favorite cities. I can't see how it could possibly go higher. It's really great to be here, and I've enjoyed my time so far. And I think my wife is really having a great time too. So my name is Sebastian Seung, and I'm a neuroscientist. I've recently wrote a book called Connectome to introduce a new idea and a new field of neuroscience to the world. And this book is actually being translated into Japanese. So if you haven't had enough of me, by the time I've stopped speaking here, you can go out and buy this book next year and read in more detail about frontiers in neuroscience. So this book is meant for the general public, but it's also been read by my colleagues. And the idea of the Connectome, the idea that a map of the structure of the nervous system could be as influential in neuroscience as the map, the genome, the map of the sequence of DNA inside a cell. The idea that that could be so influential and possibly revolutionary in neuroscience has been very controversial. And it turns out that this controversy is really partially philosophical. It's not totally scientific. And it's mirrored in other disciplines. And in fact, Fio just referred to it. And so I will start with this quote, this old chestnut, from Louis Sullivan, the famous American architect. And it goes like this: "It is the pervading law of all things organic and inorganic, of all things physical and metaphysical, of all things human and all things superhuman, of all true manifestations of the head, of the heart, of the soul, that the life is recognizable in its expression, that form ever follows function. This is the law." Now, I don't know much about Louis Sullivan's life, but I can tell that he was a man given to exaggeration, because I might believe that it's physical things, but I'm not sure about metaphysical things. And indeed, I would say that these days, there's a lot more skepticism about the idea that form and function are intimately related. And we can speculate about why that might be, but let's take an example. For example, this. This is a wonderful artifact, a drinking glass. It has a function. It allows me to drink some water, let's say. And it has a form, and we can easily perceive the relationship between the form and the function. Now, last night at dinner, I think it was Joy who asked, in the last 10 years, what is the greatest advance in design? And we all scratched our heads, and Neri Oxman was the only person smart enough to actually say anything, and she said, it's this, it's the iPhone. And the iPhone is remarkable because of its seemingly completely disconnected relationship between form and function. First of all, how many functions does this object have? It's not like a glass. Hundreds, thousands, tens of thousands of functions. And its form, a little rectangle like this, doesn't seem to have much to do with any of those functions. And so this, I think, is the reason why we are very skeptical about the intimate relationship between form and function. And I would submit to you that this might be something that people thinking about cities should wonder about. Because architects and city planners, one of their prime ways of making the city a better place is the control over form in space and time. And yet, if the digital world has broken the relationship between form and function, surely that must have powerful implications for what our cities will become. So I'm just going to throw that out there. Maybe it will provoke some discussion. Now, there's another take on this, which is that the iPhone has not broken the relation between form and function. Instead, there is still a relationship, but you need a PhD in electrical engineering to understand it. A naive look at this form with our own naked eyes will not tell us what even the form is, because we can't see it. It's embedded inside the microelectronics of this phone. And so we could do another take on Fio, which is not that he has broken the relationship between form and function, but again, that using the properties of materials that the relation between form and function becomes very subtle and very complex. And that is another possibility for the world of design and the world of cities, that this relationship will become much more complex. All right, so that's the general philosophizing, and I should say that it's the manifestations of the head. It's the mind which people are very skeptical about. Is there a relationship between form and function for the mind? You've all seen a brain. It's covered with all those wrinkles. Does that form tell us anything about the function, about how the mind works? And that's a very controversial topic in neuroscience. And my book makes the claim that indeed there is a very intimate relationship, but it's very complex. That if you look with a naked eye at a brain, there's no way to see the form that's relevant. You've got to look at a very, very small scale, at the nanoscale even, at what the structure of the brain is really like. And that we have to do that. That's the only way to ever understand how the mind works. That we're already familiar with the idea that Alzheimer's disease is accompanied by changes in the form of the brain. Holes appear in the brain at the late stages. Neurons are dying. There's clearly material destruction happening in the brain. But there's plenty of other mental disorders like schizophrenia, autism. If we look at the brain, we don't see anything wrong. And in other organs of the body, we know that's the case, that in the heart, if we have a heart attack, there's clearly something wrong with the form of the heart, material destruction. The same with the liver, the same with the kidney, but still, within the brain, we don't see that. There's many psychiatric disorders which are hard to believe are truly brain disorders because we can't see any alteration of the form. Okay, so now let me give you a historical figure, Santiago Ramon y Cajal, who was the first person to try to relate form and function in the brain. He lived around the same time as Louis Sullivan. He looked into his microscope. He wanted to go beyond the naked eye and look at in his microscope at the forms of neurons. So you've all heard about neurons. There are these special cells inside the brain that have fantastic shapes. They have branches that go in all directions. And so he made these wonderful drawings of neurons, and he in fact discovered some facts he speculated about how neurons function just based on how they looked. Now, today, we'd like to go beyond this because it turns out, due to limitations of the light microscope, he could only see a few neurons at a time. He could only see, you could think about this as a jungle or a forest of many trees, and he could see only a few trees while all the rest remained invisible. So a number of neuroscientists are working on methods for trying to see all of the neurons in the brain at the same time, to see their structures. And I'll show you a few visuals to illustrate how that's done. Here's a tiny piece of brain. It's been embedded in a hard plastic resin. And then it's put into this high-tech version of a deli slicer. It's like cutting salami, but the slices are extremely thin, maybe 30 or 40 nanometers, so 1,000 times thinner than a hair. And those slices of brain, they float onto water that's inside that blue tub. There's the world's sharpest knife, the diamond knife, which is on the edge of that tub. And slices of brain float onto the water, and they're collected by this conveyor belt. And you may see small little gray spots where the brain slices are. And then we take that tape and we cut it up into strips and we mount it on a silicon wafer. And here's Bobby Kasturi. He's a collaborator of ours at Harvard University. He tapes those strips of tape glues those strips of tape to the wafer. And we're going to see what one of those slices looks like. So we'll zoom in by a factor of 100,000 times on a very thin slice of brain tissue. And you'll see large white spots right now. Those are the round parts of neurons, and in between those spaces are the tangled up branches. Except this is all in 3 dimensions. The structure is 3-dimensional. So we take images of many many slices, and we stack them up. And it's hard to see anything that looks like those neurons. What we can do is color in the cross sections of one branch of a neuron, slice after slice after slice. And if we do that over and over again, we can build up a three-dimensional reconstruction of a small part of a branch of a neuron in red. That's called a dendrite. And in green is an axon. That's a branch of another neuron. And they touch at two locations. Those are called synapses. You've probably heard about synapses. And if we zoom into the inside of the green neuron, we can see little round bubble-like objects like these. Those are called vesicles, and they contain neurotransmitter. You've probably heard about neurotransmitter like dopamine or glutamate, the chemical signals that pass inside your brain. And so when the green neuron wants to send a message to the red neuron, it releases the contents of one of those vesicles, and the red neuron senses those chemicals. So I tell my students that even when you're thinking the most refined thoughts of philosophy or religion or romance, your neurons are still just spitting on each other. I hope that translated okay. All right, so I've shown you that we can trace out the branches of neurons inside the brain, and we can find the synapses, the points at which they communicate with each other. Those are the famous connections between neurons. And I should tell you that those neurons don't exist in isolation. That cube has many branches of many neurons inside of it. It's a very complex structure. And that's just 6 microns on a side. So 6/1000th of a millimeter on a side. That's the complexity like that. The total amount of wiring inside your brain is a staggering length. Total amount is about maybe millions of kilometers packed up inside your skull. So the wondrous capabilities of the mind are somehow based on a very complex physical structure. Now, what could we get out of this structure? Well, that's what brings us to the connectome. If you can trace all the wires and find all the connections, you should be able to find a complete map of all the connections in the brain. And this has only been done for one organism. This is a worm called C. elegans. And in the 1970s and 80s, people sliced it up really thin, traced all the connections, and they made this map. So, Joy, what does this remind you of? What's that? The internet. It reminds Joy of the internet because he believes in technology, and indeed, what else does it remind Joy of? City? So Joy spends most of his life on airplanes, and so I thought that he would say that it reminds him of the map you see in the back pages of airline magazines. And so imagine you take every city and you replace it by a neuron, and every flight between cities, replace it by a connection between neurons. In this case, this worm's got 300 neurons and 7,000 connections, kind of like a pretty good-sized airline company. Now, your brain has 100 billion neurons and something like 10,000 connections per neuron. So it's much huger than this. Would never fit on the screen, wouldn't fit in an encyclopedia. It's a huge amount of information. And what's in that information? Well, I'm not going to talk about it now, but maybe in the workshop later on, I will discuss the problem of trying to relate the structure of this network to its function. How can we explain the mind? And in particular, one really deep question is memory. How are memories about the past stored in our brains? The leading theory among neuroscientists is that every time you have an experience, the connections between your neurons are somehow altered. That this diagram, which you have, changes each time you have a new experience. And that's how memories are stored. It's still a theory, really, but we're trying to make the techniques by which we could test that theory and find out if it's true. And that's why Santiago Ramon y Cajal, our hero from over 100 years ago, made the claim that every man can, if he so desires, become the sculptor of his own brain. I'd like to add one more thing about the session later on, which is there's a game here. And to give you some understanding of why we have a game, which engages the public to help us map out neural connections, that cube you saw was colored in, right? All those branches were colored in. That took about 250 hours of human labor by my postdoc, Daniel Berger. And I can assure you that Daniel is much better at this than you or me. And if he were to color in the wires of a piece of brain that was just 1 cubic millimeter in size, it would take him about 100,000 years. So we need to figure out ways of accelerating this process. We've used machine learning. So we've used artificial intelligence, trained a computer to emulate Daniel as well as possible. And that computer, by working with humans, can speed up the process by cutting the time required to color in those neurons by a factor of 10 or 100. But we still need people to help. And so we've created a game called iWire, E-Y-E, wire.org. And we have over 80,000 registered members who play a game. They color neurons, and they have fun, and they help us discover things about the retina, which is why it's called iWire. And we've just discovered something. We think we've solved a 50-year-old mystery, which is how the retina detects moving stimuli. It's eluded neuroscientists for 50 years, and 1,678 iWirers are going to be co-authors of a paper that we just submitted to Nature. So we'll talk more about that later this afternoon. Thanks very much.
Thank you, Sebastian. And last but not least, Liz.
Well, thank you so much. Thank you for the invitation, and it's, wow, what incredible acts to follow. I'd like to, first of all, among these very techno-savvy guys, I'm going to seem really like a primitive, but to start to think about architecture in relationship with technology is part of our everyday. It's really, one can't think architecture without technology, and we design with sophisticated analytical tools and modeling tools and fabrication tools and also monitoring. And we're pushing materials to high performance levels, and we're also exploring new materials. But nevertheless, architecture remains relatively dumb. It's generally static and slow, geographically fixed, and it's integrated into legal systems and social conventions. And it's a practice which requires consensus building and lots of money and long lead times. And while architecture is in many ways behind all sorts of technological research that's happening in other fields, I actually prefer to think of architecture as a very sophisticated technology in and of itself, because it's a construct that puts other systems together, like economies and politics, and issues of culture and society. I am considered the glue here that connects lots of different practices, and I just wanted to very, very quickly just go through a couple of things that we do. We work a lot with materials that are less sturdy than typical concrete and steel, like water, mist, air, low pressure air, and as well as pushing new materials. But what I wanted to highlight here was really two interrelated projects that go in a different direction, require a different part of my my brain, Sebastian, you could help me analyze what it is. And but in the past 10 years, my studio has been working on projects in New York and also some other cities, and mostly actually cities that have problems with urbanization. But New York, you think New York is really sophisticated. Well, it's got severe problems as well, namely lots of infrastructure that doesn't work. But we have been working on the High Line, which is a 1.5 mile stretch of industrial railway, which is in the meatpacking district. And just to show you a little bit, meatpacking district is here, Hudson Yards is here, and this is about 1.5 miles, and we're 2/3 of the way through this project. The way the High Line works, and we got involved in a competition to really rethink this piece of infrastructure which has gone into ruin. And this is what we found when we went up there. It was illegal to go up. It's about 30 feet in the air, and it's managed privately. And just to go into a little bit of the history, this is what you actually see from the street, so it goes right through buildings. But just very little, short bit of history. This is in the mid-1800s, and you could see a train that's going right through Manhattan, and basically that train delivered goods to this section of Manhattan. And because there were so many pedestrian and train conflicts, so many deaths, that they hired this cowboy basically to lead the train and clear the way for the train. And then in 1929, the High Line was built, and here are some blow-ups of that. So here we go. The High Line is built, and it functions to distribute goods through this part of Manhattan for about 50 years. And so, and this happened until the highway system was really developed, and at that point, this became fairly obsolete. And in the 80s, the artists started to move in. Actually, Dia Foundation found its home there, and it started to change very slowly. In the late 80s, there was a lot of pressure because this area of Manhattan was very burnt out. It was very neglected, and so there was a huge amount of pressure to demolish the High Line so that the property owners that owned those properties could ultimately build new structures. And so much pressure was put on that actually 5 blocks of the High Line were demolished. There were a group of very young guys, I think I have a picture in here, of these 2 citizen activists who decided, hey, the High Line could be converted into a public park. Why don't we start? And they were naive, and that's the only reason why they were successful, was because they were naive. And one of the things they did to change public opinion, because nobody really even understood it, was to commission a photographer, Joel Sternfeld, to take photos of the High Line different seasons of the year. And okay, so this is what it looked like. These are the guys, 2 young guys that left their day jobs. Okay, this is a slight delay. So they argued for the High Line as a park, citing Central Park and the way it catalyzed development all around it. And they said that the High Line would do a similar thing. So more Sternfeld photos. I'm having a little bit of difficulty here with the control. So anyway, the last act that Giuliani had as mayor was to demolish the High Line, and those photographs were ultimately published in the New Yorker, and they had a fantastic effect. The public, for the first time, could see what the High Line was, what it could actually be. So fast forward, there was a competition, and We won that competition at the same time. There was a new mayor that came in, Mayor Bloomberg, and there was an understanding at that time that, hey, perhaps this area of Manhattan could be developed. And so they changed the zoning in this area just around the High Line to enable whatever growth was there to not impact on the light and the views of the structures that would be there, and to allow the park to actually breathe. So when we got involved in the High Line, we were just fascinated by this as a ruin, and just what actually just naturally took place there after 1980. This is kind of what grew by itself. It was self-seated, so seats that flew off of train cars, just basically were planted in this ballast, this loose ballast, and different things grew in different territories. So there was a very interesting set of ecologies, microecologies that evolved in the whole mile and a half. And these are just a couple of different grasses that grew there, but there were over, 100 species, some native, but mostly not native, that just kind of were planted there. And so when we arrived, we just thought that this was beautiful, but how would the public use this? And I don't know about this controller. Doesn't seem to be working. Okay. So maybe I can say next if it's not working, and we could advance. Anyway, so the big question was how would the public come into this very otherworldly place? It shouldn't be like this. It shouldn't be a place for humans and a place for nature. And we thought, well, maybe it could take its inspiration from these kind of natural decay cycles that happen with culture over nature, over culture over nature. And that was really the inspiration. Next, okay. So we called the strategy, and basically this was the main idea, very, very simple, called agritecture, and was a little bit of agriculture and architecture combined. And the idea was to digitize the whole surface and break it up into planting, into areas of green and areas of hardscape, and put it together. These are just very small units, put it together in different combinations to produce 100% hardscape and 100% landscape, and every combination in between. And the units look like this. They were varied. And then we added plants, so we did this with Pete Udolph and field operations. And here are just some of the plants. Now, I should say that we were very enamored of the kind of melancholia that was there. It was a sense of a kind of irretrievable past, a beauty of the irretrievable past, and also a kind of concern about the unknown future. And if we were successful, well, how would the future really look on the High Line? I'm going to show you some images, and maybe we could just go next. Next slide. Okay, and you can, next slide. And here you could see the language is very, very simple. The planking becomes the seating, the lighting is embedded in existing surfaces. Next. Okay, some more views. Next. Just very simple lighting. The High Line goes right through buildings. Next. And then repurposing some industrial infrastructure for a culture of leisure. These lounge chairs. Next. 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 And next. So the High Line, the site around the High Line is changing so much now that some of these shots that were taken early on of a kind of abjectness of New York, these sites are already gone, and they're already starting to be built on. Next. And one of the great things about the High Line is that there is so much that is really unexpected. And it's a space of collisions. It's a place where things just inadvertently meet. And this is really one of the fantastic things, because you're 30 feet up in the air. You're seeing New York in a way that was never intended to be seen, with blank party walls and smokestacks and mechanical car lifts and billboards. And so it's a place where you really find a different New York, a New York that New Yorkers don't even know. Okay, so we have built basically 2/3. We built about a mile of the High Line, and what happened was the notion of the High Line being a catalyst for development was we just underthought that. We didn't realize just how popular it would get. And in the end, what was an eyesore became a huge amenity, and also it escalated line prices all around it. And here are some of the buildings that are being built around, and actually since this diagram, many more. So it's really taken off. This is a portion of the High Line. It's one of the spurs across this 10th Avenue. And we did something very, very simple here. We just cut out the steel, and we put a little kind of theater seating in it, and we converted the steel plate in the front surface into glass, and created a little theater where the public can just look at 10th Avenue. And the theory here is that the reason for the popularity of the High Line is we've introduced New Yorkers to something that they don't really know, which is the idea of doing nothing. New Yorkers, like most urbanites, are always productive. If you're not at work, you're on your devices, messaging people, and or if you're at the gym, you're burning calories, and that's productive, or you're walking your dog, but you're never really doing nothing. And the great thing about the High Line is that it's a sanctioned place for nothing. And you can't really throw a ball here. You can't bring a bike. You can't bring rollerblades. Really, there's nothing you can do but walk and sit. And so this is the kind of epitome. Next slide. This one site takes doing nothing to a great height, where New Yorkers actually choose to sit here and just watch the traffic go by. And to us, it's a little bit like looking into a fireplace. It's mesmerizing. It kind of calms you down. And this is something that is. In a way, it's we're talking about making discoveries about very old things. This is the discovery of the promenade and the walk. There are all sorts of things that occurred at the High Line that we just didn't anticipate. People come there to do all sorts of things, like look at the sky, or we never anticipated yoga classes there. Have these huge dinners, mile-long dinners. This was interesting. This is off the High Line. There's a window here that was inadvertently, there was a light that was focused from the construction on one of these windows. And the person that lives on the other side is actually a cabaret singer. Next slide. Okay. She's a cabaret singer. She would come out every night at 7 o'clock. And she would perform for people on the High Line. Really crazy. Next. There she is, the Renegade Cabaret. So you can plan all the things you want, but really what happens in urban space is the unexpected. It's even better than anything you could have imagined. Next. There's a hotel that spans the High Line. It's all glass. Next. And so people started to perform because They just started to perform there. And next. And we actually couldn't stop it next. But there was something incredibly consensual about it. The public liked to look, and people in the hotel liked to perform. So it's a kind of a strange thing how the High Line has become this kind of pop cultural thing that we can't, we see it everywhere on TV shows and movies and comic books. Next. Okay. Next. There's even a perfume that is named after the High Line. It's very bizarre. I don't know where the tagline is, but it says it's something like it has all the smells of urban renewal. That's okay. Next. So now we have kind of created something that we didn't realize that we were doing. High Line went viral. And now there are High Lines going up all over the world. Next. These are just some of the places. Next. And so one of those inadvertent consequences of doing something that's kind of an asset in your own city, it became this model for the saving of infrastructure in cities around the world. And in making public spaces. I mean, I think that in our technologized world, there is a deep need somehow to go back to basics at the same time, to balance one's life. And so these High Lines are really proliferating everywhere. The accidental ecosystem that we found at the beginning of the project has spawned this new ecosystem in which natives, tourists, artists, executives, socialites, club kids, cruisers, retirees, sunbathers, fitness buffs, fashionistas, and even flashers produce a new kind of bioversity that's pure New York. So maybe also this kind of beauty of the High Line that people react to is the sense of nostalgia and a sense of apprehension. The past, looking at the past that we can't bring back, and looking at the apprehension of an uncertain future. Full of gentrification and of higher rents now all around the site. And there is a kind of moment right now where gentrification and vacancy are in perfect balance. So I show this, and I'm going to quickly show one more project that's attached to this as a product of citizen activism, bottom-up construction. So we didn't wait for the city to decree this a park. Two guys kind of just did it, got everybody involved, got architects involved. We went through a huge process to get the city to really understand what it means to have security 30 feet in the air, how to dispose of garbage 30 feet in the air, things that a conservative city didn't really know how to do, how to actually without any funds to maintain a place like this. So it was all kind of invented from scratch. Next. So very quickly, I'm going to show a project that is ground up, that we as architects invented kind of and proposed to the city, and now it's happening. It's at the very last third of the High Line, and on a site that is right around here. So the High Line that you just saw is coming up this way and is coming around the yards. And so this stretch of the High Line is to the development side. So this is Hudson Yards. There will be a huge development here of over like 26 acres and 13 million square feet of mixed-use development on this part of the site. Right now, it's the east yards. Okay, sometimes this works. So there was a very small segment of this very large development. This how high it's going to be, 21,000 square feet, and it was designated for culture. Now this happened around 2010, so the year before. It was the beginning of the economic crisis, and the city put out an RFP to ask, well, what kind of cultural institution wants to be here? Do you have any ideas? And no cultural institutions actually came forth. No one wanted to expand. No one wanted to build from scratch. There was actually very little money around. And we started to think about cultural institutions. Well, what does New York not have that it should have? And what can it do to be different from other cultural institutions in the city if it actually is ever created? And one of the most important things about this was to be able to make a financially self-sustainable new cultural institution. That is, it wouldn't be dependent on government money, which doesn't exist in America, and it wouldn't be dependent on private philanthropy, which is more the way that cultural institutions go. So that was the starting point. And then what does New York not have that it should? Next. Okay, so the location of this is right there. There's going to be the Whitney Museum is moving from uptown, right there. So this is another cultural anchor at the end of the High Line. Okay, so what New York doesn't have is an unbranded cultural institution, sort of like a Kunsthal. Every institution like the Metropolitan Museum, the Guggenheim, the Whitney, MoMA, they're strongly branded with a strong history and a strong mission, but we don't have anything that's loose that could take traveling shows, that could do big experiments. We don't have a truly multidisciplinary place where visual arts and performing arts can be together, but we added one more thing, creative industry. We don't have a building that is truly flexible in terms of its scale and in terms of adaptation of technology, and it certainly doesn't have a self-sustainable place. And we invented this idea of global timeshare. So the main idea here is that there is a base building with a shed, and the shed opens up and expands the footprint of the base building. The base building has 3 large column-free galleries. And the way that the shed moves is based on gantry crane technology, very old system, but made more contemporary. The reason why it doubles its footprint is to have small shows or extra large shows. That is, you don't have to consume a lot of space if you don't need it. So you just take it when you need it, you heat it when you need it, but also to be able to have exhibitions and at the same time have a function that can take place, that could be income producing, income generating, but also does not disturb what's happening inside of the main galleries. So in order to actually do this project, we also took on the design of this residential building, which is something my studio was never thought that would ever do, a big commercial high-rise, but we did it in self-defense. It gave us more space for our offices and for shared infrastructure, but it also it made us make it produced a better neighbor for us. So we took on this, and okay, so this is, next slide. Okay, so in and out. And then just a word, just a couple of slides about the tower itself. You see it goes from square to cloverleaf, goes from rental to condos. Next. And next. And it's just, most buildings have bases or tops. This building has a middle, it has a corset, and it goes through that translation of geometry. Now, I should say that this was an incredible project for us to be involved in because we were able to, and totally different clients and totally kind of related but unrelated. We're doing an urban park for New York. We're doing a new cultural institution that we had invented that was really a startup. And we're doing a residential tower for the developer of the site. So we were able to do an ensemble and actually think about it all together. Next. So this little animation is now looking from the north, and you could see the shed. It docks into the tall building. And then in 15 minutes, it can deploy, and all the guillotine doors can come up, and it could be open air. And so we imagine having lots of different kinds of programming where we can have thermally controlled events inside and exhibitions, but also events that are open air and free to the public, the whole range of things. Next. Okay, this is the basic programming structure, which is it produces, co-produces, and it presents all different types of exhibitions and performances. And then it has income-generating events, and they're all related to creative industry, and then all the things in between. So it's kind of unabashedly a kind of mix of culture and commerce, and usually one apologizes for the other. Many cultural institutions have to take money from commercial sources, but we do that unapologetically because we are bringing up the level of the commercial stuff that's shown, and it is all creative industry based. So you can see all the different modalities of the culture shed, and with a program that's very complex, four-dimensional program, it's very, very rarely ever private. It's mostly public, and often public and free. Next. Okay, and then these are just some views. Next. The gallery. Next. And then the shed itself. ETFE pillows. Fashion Week. Next. Performances, all sorts of spectacles that could take place. Next. And then it could be opened up as a farmer's market. Next. Skating rink, or many other functions that could be seasonal. Next. And when the shed is nested, also has a very large space, the one that it covers, that could also be open air for concerts. Next. And then to the north also there's a very large space that's conducive for concerts as well. So the New York Philharmonic, for example, could play indoors, and the public can pay for a ticket, and there could be broadcast outside. Public can witness in real time, but 5,000, 7,000 people can watch. And so this is the last slide, and I would just end by saying that both of these projects are really conceived ground-up projects, and for us as architects, we're very used to inheriting projects. There's a need, you get hired, and you execute your project on time and on the budget, hopefully, and you contribute in some way to the culture of architecture along the way. That's always been our goal. But we had never thought until recently about being able to be part of policy making and to put things on the table that actually cities will never think of, and administrations will never think about. So this project now is a 501c3, which is a tax-exempt organization that is a cultural organization, so it has a federal status now. It now has all the legal permissions to be deploying onto a site that is actually not, was not granted as part of the cultural site. So we went through all sorts of zoning actions and legal actions to be able to make that happen. The city was very, very supportive of this project and helped us on the legal front, and also to start up the fundraising that it needs to do the capital campaign to get this built. And at the same time, we're working with artists and curators and museum directors and festival directors and people from creative industry to to really preconceive this program, because in a sense, we were very opportunistic. The site was there, the ability to build something was there. We wanted to capture the possibility and to do something that has a certain flexibility before there was actually ever an institution. So usually architecture follows from a program. Here, architecture actually instigated a new program that was never conceived for New York. And as we show this project in different parts of the world, we see that actually it's an idea that, that seems to be somewhat infectious, and many cities are saying, well, why don't we have one of those of our own? So that's all I have, and thank you.
Thank you, Liz. And can you guys join me on the stage? So for people who are following this on Ustream, and we're going to, by the way, switch to English, there's a hashtag, which is ICFTYO, and we'll be following the stream. So if you have any questions, we may take some questions at the end from the stream. But I thought what I'd do is let me try to summarize a little bit of that, and then maybe we can have a little bit of a discussion. One of the things that I found really interesting in Sebastian's thing about the form and function relationship, and Liz, you talked about sort of architecture follows institution, but now you have institution following architecture, which I think, we've had activism in cities forever, but I do think that technology is empowering both the ability for groups to get together and like social networks and things like that, but also the other thing that Fio and everybody I think was connecting on was that the science of materials and the science of, and also there's the science of innovation is accelerating, and I think that that also changes, and you mentioned that architecture is sort of very permanent and it's kind of very solid, but we start to look at materials that, I guess I could use this, that change and are more malleable. And so, and thinking about, with the iPhone example, for instance, the extent to which the technology is embedded in the form, like the iPhone or some of your embedded devices. And I'm just going to rattle off things and then we can talk about it. And then I think the other thing that is probably new to this crowd, and was new to me before I went to MIT, which was the extent to which science matters and is now becoming and having more and more impact. And I think the science of information technology has sort of recently become, everyone's become aware of the impact that it would have on things like cities. But the science of biology and how much biology is now inspiring both literally and metaphorically things that we're doing in the real world. And we saw earlier Neri's work, which is very biology inspired. But also then you have things, people like Sebastian and Fio, who are taking engineering, and it's biology that's inspired by other things. So we're inspiring both ways. And I think that you had this thing about interdisciplinary, and at the Media Lab we use a word called anti-disciplinary. So this is going to be hard to translate, but interdisciplinary, which is something that in the last decades everybody thought was an important thing, which is for architects to talk to mathematicians, to talk to engineers. That's interdisciplinary, when you have different disciplines talking to each other. Anti-disciplinary is what you guys are, which is you don't fit in a discipline, or you break the boundaries of the disciplines, because even interdisciplinary, it's kind of like one ministry talking to another ministry, and it's not, it's still a ministry, but a collection. And now we have this new space, which is the ability to pull in whatever you want and inspire whatever you want. And I think that if we were going to try to tie it a little bit to this event, I think one of the first things that's important is to give yourself permission. I think one of the key things about the internet was that it was a permissionless innovation system. Because in the past, with telecommunications and things, you had to have a permit, you had to have permission to connect something to the telephone network, or you had to have permission to open a telephone cabinet. And the internet is the first technology where you don't have to have permission to do anything. You can do whatever you want. And whether that's in a city or whether that's with biology, I think you represent a new category of academic who doesn't actually feel like you need to have permission to do whatever you want. And I think one of the earlier questions that we had was, should cities be designed by somebody with strong leadership, or should it be bottom up? And I think Mr. Tsuji, who's the CEO of Mori Building, said, well, we'd love for it to be bottom up, but he still thought you needed control. But I think the relationship between the sort of emergent behavior that looks like biology and a designer, and this is what you're doing in the cities, is you're enabling the biology to flourish, but you're tuning it. I think that's what I sort of felt like, and the fact that you were inspired by the decay and the biology to design it in a way. And I'll finish with this. I mean, one of the things that Neri says very eloquently, and what I believe at the Media Lab we're trying to do, is that in the past, technology, science and technology has often been about building efficiency and trying to maximize your gain at the expense of the system, at the expense of nature. So we have a broken ecology. We have climate change because we have been very selfishly working on science and technology for local gain. But I think the future of technology, science and technology, is that you have to look at the entire system. It's very complex. You don't really know exactly what's going to happen. But I think that all of us as scientists and as architects, I think you now need to think about the thing as a complex system rather than how am I going to get this to go faster. And your whole thing about the New Yorkers don't know how to not do anything. I mean, I think the problem is we've got things so efficient and so fast that now we suffer from fluctuation, amplification, and unpredictability. And what we need to do is now have science and technology merge with nature so that we're thinking about natural systems rather than thinking about sort of interventions that just try to gain efficiency. And I think we can apply that when we think about cities, because just making them more efficient isn't really what we're trying to do here anymore. So those are some thoughts. But I don't know if you, having listened to each other's things, or based on what I have, if you have any I know, Liz, you helped bring it together with the city.
Well, you opened up a lot of territory. I don't know. I guess I'll just anywhere in there. Permission, maybe on the issue of permission. We, as a female architect. So people often ask, well, do you feel like you're an outsider and it's difficult for you, or as someone that does different, that's interested in different media, how does that? I actually, I think about my own career. It's been so fluid that I never really think about being a female. I don't think about being an architect or being an artist or being someone that's interested in performance. And this acknowledgement just recently, this notion that a different kind of empowerment, because my studio has always worked from the edges, right? Because of the way that architecture was so impenetrable in a certain way. We could do our own work outside the system, but the moment that you touch the system, it was very, very difficult to actually penetrate it. So the architectural work that we did was in academia and in the street, public art, public interventions. But I think it was maybe a combination of the government in New York right now that has been very progressive, that has been possible to penetrate and actually think beyond the limits of what architects and planners do, to maybe push a little bit on the political front. And so, yeah, these days, I don't know what's going to happen with the next administration, or if I were transplanted into another part of the world. But architecture and cities are, as I mentioned before, they're expensive. And while in various researches that you guys are doing, you're doing it under the protection of university, right? When you do that in public space, all of a sudden you have all sorts of legal obligations and restrictions that are, so limiting that it kind of takes your spirit away of experimentation. You have to work through so much. So I think that is maybe one of the great challenges of converting research into actual physical action, taking action in cities, that there's just still so much liability involved and so much expense and so much time, between an idea and and some kind of meaningful change. It could be decades.
I actually have a question for, do I have to?
Yeah, I
have a question for Liz. So Joy talked about the problem of interdisciplinary or antidisciplinary work, and I think that's one interesting problem in getting people to think outside traditional boundaries. But I think Liz emphasized something different, which was the interface between creative individuals in any discipline and society as a whole, the political process. And that also happens in science. For example, the Obama Brain Initiative now. President Obama announced that the United States should invest a large amount of money, actually it's not even that large, a medium amount of money in brain research, and it's not clear what should be done. And neuroscientists have to make some kind of consensus or advise the government on what's the right way forward. And so there's a question of political process. How are creative people, innovative people going to engage with the rest of society? And so my question for Liz is this something new for you? How did you learn how to do it? And do you feel that your discipline is somehow neglecting that? So kind of three related questions.
Interesting. Speaking for not my discipline, but myself and career of my studio, we came in from as kind of like grenade throwers, always at the outside and critiquing what was happening in the institution, what was happening in the discipline. And at a certain point, I think that the leadership of institutions was taken up by people of my generation, and all of a sudden there was really not much to complain about. And so, then the question was, how do you actually, can you speak in the voice of the institution, or can you speak in the voice of the government, or and that was something that it took a while to understand, that there's a place that could be critical and generative at the same time, because I thought one was really exclusive to the other. So I think it is somewhat lacking in the discipline. The discipline tends to be fairly autonomous these days. I mean, it's very different from maybe the spirit of the 60s. It went progressively more into its own kind of expertise and the expertise. And it's interesting because in my world and my colleagues, there are many of them that are inspired by science, but use science as metaphor and not really like the deep research and trying to convert, and also research into new materials and the deep research. So I think that there's a lot of work to be done in my discipline to be able to sort of break down the conventional thought that the only place to make strides is somehow outside, and architecture is for the bureaucrats, and I think that really has to change, and architects need to find more agency.
Yeah, and I think it's interesting, though, looking at Sejima-san's presentation in the keynote as well, the extent to which architects and city people are really looking globally, and I think this also helps with the internet, and there's so much connection, and there are cities that we can use as labs. So, for instance, I've been working a lot in Detroit, and Detroit is utterly collapsed, but it's now getting full of artists, and I'm on the board of the Knight Foundation, and we just gave 58 arts grants in Detroit, and a lot of them are on the edge of legal, or actually illegal maybe. But the thing is that it's so collapsed, it's sort of, a lot of it is almost like it's better than nothing. I mean these are abandoned areas, and there's a really interesting kind of, and even if you look at sort of the areas of New York that the artists flock to, they tend not to be those places that are, they're the abandoned places, where you have cheap property, you don't have a bunch of stuff around, the artists move in and then it gets gentrified. And it ties to this, it's a very interesting kind of thing. And I think New York is interesting because you've got labs in your own backyard. But I think also looking at some of the cities around the world and testing things where they don't have as much regulation. And I think in biotech we do this too, where you go to countries with a little lighter regulations to maybe try to develop things and things like that. So I think thinking about it globally and thinking about living labs for cities is also another thing that we can try to get around that regulatory stuff.
It's interesting. I just want to bring up a related topic, and that is the this romance with the garage, right? Where the site where all brilliant inventions take place. And, it's like these are becoming landmarks. But it really touches on a romance that we also have around the arts, that great innovation happens in derelict places. And, so yes, the artists find these really cheap spaces, and then that brings in, artists bring in galleries bring in boutiques bring in condos. Artists are far gone, they're into the next site. And it's always the sites that are attractive are the sites that are cast off. And for us, it's a real kind of I would say challenge to make a new institution for artists, that one could feel a kind of joy and exuberance around something new.
Well, there's a similarity, I think, to what we have to do at the Media Lab, which is how can you be at the center but make it feel like the edge? Because what happens, and this gets to your politics, if peer review and traditional science reinforces a behavior of really being kind of in the center and not taking risk. And the reason why the kids who are on the edges in these bombed out derelict places come up with the invention is they don't care about risk and they have nothing to lose. But you want to create that in an environment, whether it's in Tokyo here at Mori Building or in the middle of New York or at MIT. How do you create, and the way that we do it, interdisciplinary gets back to this, which is if you just collect misfits, if you collect the people who ignore permission, you actually do create a culture of edgy innovation. And you really have to work hard to keep the normal people out, and so it's interesting in Japan because Japan tends to reinforce a certain amount of obedience. But one thing I've noticed in Japan, and you may have noticed this here, like you look at Nanjo-san, he's the most irreverent and disobedient person I know. And Japan is really interesting because they put those people on the top of institutions. So Mr. Kurokawa Kiyoshi, who is going to be at the panel at the end, he's also, I think, one of the top people in academia in Japan. But he's also completely irreverent and completely chaotic. And what's interesting is that in Japan, with this kind of focus on people being normal, they do celebrate the misfits, and I think that that's kind of the interesting thing about how do you institutionalize the ability for people to be on the edge.
Well, I think that there is a need for that, and that needs to be fostered. But I do like also the fact that you have to build, whether you call them misfits or whether you call them idealists or visionaries, there has to be always a component of pragmatism in order to foster that. You were mentioning law systems. I can give the analogy. Science may be may be centered and may have a formalism. But for example, if you're trying to revolutionize medicine, so if you are actually trying to get these implants available, then suddenly you are back in the law game, because then it's regulatory commissions and it's the Food and Drug Administration and it's approvals. And so it's almost a barrier to an innovation that exists and that is poised to exist. So I think in all of these cases, the misfits have to have that shred of touch to reality, and that's probably the edge that you're talking about. I think
and sometimes you can call it art and get away with it.
That's true. That's true. That's true.
No, but it's a really important point that one, I always use that word misfits for everyone that comes to our studio, because they can't work anywhere else. They usually get fired, or they just don't qualify, and they somehow, can work in our environment, which is totally chaotic. And it's a good word, but it also, there is, if one desires to actually make change, you have to be able to walk both sides. You have to be able to talk in different voices, and you have to be able to have empathy, actually, and you have to, those legal systems that are there to protect us also from, fraudulence and lots of things that could be very dangerous for us. It's interesting that the rules that are made to protect us are often become so encrusted that they prevent interesting things from happening, and it's beyond, beyond the protection. And so I think that's another place for us to somehow be involved in, is the legal structures that created the kind of framework for our own disciplines. They deserve to be looked at again. Like in architecture, building codes, they were there initially for health and safety, and one has to think about why all buildings kind of look the same. If one is to follow health and safety, one could do it in a million different ways. Codes can be a detriment.
And in Japan, I think there's a process where we create zones where we have certain types of policy changes or exemptions. And that's a thing that I think Nanjo-san's also trying to make a little art zone. But I think that's one way that we're trying to experiment with it in Japan. And you can also see it in other places. But I do think that kind of trial and experimentation, and also the university does provide, like for instance, for us, Kendall Square is a lab. Our building is a lab, although still getting Neri's silkworms hanging in our pavilion was a little bit of work. But it's probably easier than doing it in a real public space. But I think what's interesting is to try to think of kind of these nested labs where you have the first stage inside of a laboratory in a university, and then you do it in a community nearby, and then you do it in a special region, and then you do it in a small part of a real town, and then you expand it out. And I think when we're talking about innovation, innovative cities, I think as city planners design cities, I think it's important to start to design, here's a zone where we're going to allow people to experiment. And it's like you hacked New York to do it, but I think you could, if Mori Building wanted to, they could say, okay, well, this is an area where we're going to play with new ways of thinking about art or new ways of thinking about technology, and then stage that up. And I think that the reason we didn't do it before, but we should do it now, I think, is the rate of change is so fast that, for instance, Japan is now trying to figure out what are we going to do for the Olympics 7 years from now. Well, we don't know what the technology is going to be like 7 years from now, but they need to start building now. And I think what's important is to build in this flexibility. But I don't know. I mean, Sebastian, the other thing that you were doing is crowdsourcing, right? And I didn't mention that, but that, and I think the ability to pull people in to help with your creativity, help map the brain, and the people are starting to become a force in a lot of this. And I'm curious because I know, Liz, you look at history probably a lot more than I do. I mean, how much of this is a new thing, and do you see innovations, or maybe Sebastian, you can talk about this. I mean, do you see the crowdsourcing is increasing or changing?
It used to be called like interviewing clients, or taking polls, or just understanding. Dependent, if you're doing a public project, you would interview as many people as possible. But my students, I'm at Princeton, and my students are really infatuated with the notion of crowdsourcing in a way that almost replaces the architect as an expert. Let's make it so democratic, make the process so democratic that that buildings can automatically design themselves. And I think that's it's a huge danger. Their crowdsourcing is good for some things and not for other things. But the tools are fantastic. The data that can be mined from the internet with dependable sources are really, really valuable for architects. But on crowdsourcing, do you guys want to?
Well, yeah, so the idea of open innovation, I guess architects have had it all the time in the sense of having competitions, right? So the standard way to make sure that as much creative talent comes into design is to just have a competition and invite them to come. But crowdsourcing can mean different things. In that case, typically it's an appeal to the idea of the expert still, right? Mm-hmm. That experts are the people who enter those competitions, and we want to enlarge the pool of experts inside the discipline who will contribute. And the real question, I guess, that's less obvious is, what about people outside the discipline? What about people who are, who you would never think of as having ideas that might be helpful to solve a problem that you have? And I should say that Joy referred to my work in crowdsourcing. So we have this game, and we ask people to come and help us look at these images of neurons and map out the branches. And that's actually a very challenging cognitive task. It takes 40 or 50 hours of training at least to get reasonably good at it. And it turns out that a game is a really effective way of training people, right? Because they have fun and they keep on going, they develop expertise, and so on and so forth. And that's working fairly well. But I guess a major next step would be to engage people in all the rest of the scientific process. So this is sort of the first step in analyzing the data, but we want to go all the way down the line and open up the idea of scientific discovery. So, one notion, one buzzword I have is the idea of micro-discovery. So there's micro-lending, microfinance, and so on. Micro-discovery, the idea that anyone out there can have a small part in a scientific discovery. If we could somehow build the structure, social structures, and use technology to make that happen, I think science would proceed at a faster rate. And it's precisely what Joy is referring to here, which is this anti-disciplinary idea that often the advances that we need don't come from within the discipline. The people who are working inside, they do it their way, and they keep on doing it their way because that's the way they've always done it. We need to have much better computer science, computer vision capabilities to analyze our images, and neuroscientists don't have any expertise in that. So it's very natural to try to recruit people from outside the discipline. So, but I think we're really at the very beginning stages of trying to put experts and within the discipline, experts outside the discipline, and real novices together to create institutions that, I don't know if I should say institutions, but social structures that just generate knowledge at this incredible pace that we're getting used to, and I think we'll just get faster.
And you're kind of like a one-man anti-disciplinarian. I mean, the number of disciplines that you penetrate at once,
Yeah. Well, it's interesting though, as I'm thinking of crowdsourcing. Actually, the thing that I notice also is that there's almost different types of crowdsourcing. There's a completely anarchic crowdsourcing where you don't have any definition or any attractors or any rules, and I don't know even how to wrap my head around it, because for example, I look at the work that the crowd does with your game, and there is a very strong boundary condition. There is a painstakingly built image that then acts as the constraint that people can move through. And so it goes back to asking whether having those attractors, whether having those airports for the airplanes to fly beneath, devises a certain connection pattern and devises certain rules, and to me that's almost that poses the first question, is whether there was a question this morning about whether you impose conditions on something and then before you let it run free or not.
Well, I'm fascinated to hear that Liz's students are interested in crowdsourcing, but I think that they would effectively they would need a mechanism to teach people architecture. You have to give something in order to get something back. And so
But yeah, I have a question though, because I know you're working with one of my faculty members, Kevin Slavin, who's a game guy, and he was saying that he thought that more people would play your game if you didn't tell them that they were working on the brain. And that by telling people they're working on their brain, you're selecting. And that deception is actually a really important part of a certain category of crowdsourcing. And I think telling people that this is for medicine, or I love this, I am a creative person, that's like the last thing you want to do to make somebody creative, or even words like cool Japan, I kind of worry about, because it's sort of saying, by saying you're cool, it makes you kind of uncool, right? And so there's a really interesting design pattern, which I think architects are pretty good at, which is you don't tell people what to do, but you cause them to do it by creating this sort of environment. And I think one of the problems when we talk about things like innovation and creativity is, and then I'm going to push the question again back to you, is don't you think that maybe they would be better innovators if they didn't know what they were doing? Whether it's architecture or...
Before you answer that, would they still have the same constraint, even without knowing what the constraint is?
Or is it an ethical thing?
I think it depends. So for the particular activity, mental activity that we're asking people to engage in, Kevin wants to get millions of people playing this game, and it might pay to make it a game that's fun, independent of whether you know that you're actually doing neuroscience. I don't know. I think that's an experiment. I don't know how Kevin's a very creative guy. He's going to try to do it, but I don't know if that's the end game. So let's imagine that we have 1 million people playing a game and that's generating all this structural information about the brain. We might have a smaller number of people who are interpreting that data and trying to relate it to function. And at some point, those people have to become, I think, cognizant of what they're doing. I don't think there's any way around it. I don't see anything wrong with bringing people into it by just making it fun. And certainly, that's, in the end, what innovators are drawn to, right? They're drawn to the feeling of play, and maybe sometimes the feeling that nothing is at stake, right? Sometimes the feeling that something is at stake can kill creativity. But in the end, I think we want this higher consciousness where people know what they're doing, they know the purpose of it. So maybe, I don't know. Do I disagree with you? I'm not sure.
But Liz, looking at your work, because I think this is the artist side, right? Because the artist tries not to necessarily have the participant immediately. There's not an instruction manual for art usually, and we talked about sort of art versus design and things like that. But when you think about putting people in an environment, how much? I use deception. Deceptions, I don't know how they're translating into Japanese, but it's kind of an intentionally negative word, because I use it because you do eventually get to the point where you have to kind of make a ethical decision. But whether it's the regulators or the people in this place, how much do you design deception in your work, do you think?
Well, I never really thought about it as deception, but I maybe just another formulation of it in terms of the creative process is the analytic stuff relative to more the intuitive stuff. And there's a part of me that wants to break every rule all the time, and so instinctively I want to take a look at a rule, try to understand how it got there. So there's a lot of analysis that goes into it. Figure out whether it's applicable any longer, figure out what could replace it. And so that's the critical part. The kind of generative part usually comes from outer space. It just flies into your brain. You want to do something and you can't exactly, you have to find, where those creative ideas mesh with the critical ones, to get a project. Now, it's really hard. There's no real formula for it. The deception, but I would say that there's another kind of thing that I would really call deception that's very structured into our work, which is a kind of stealthiness that you actually need to figure out how to get what you want. Because often what you want is something that people feel unsafe about. You know, the very people that you have to get consensus around any change. So it's not so much that you cheat or lie or anything like that, but it's a kind of stealthy way of kind of pushing forward an agenda, but making people feel very comfortable that they're part of the process as well. So you mentioned that before.
That's deception. But anyway.
Maybe what you're asking would be if Liz had put a sign up that said yoga area, would that have made it less fun for people to discover that this is the place to do yoga? So at that level, I think she'd have to agree with you. But if it's at the level of having architects compete in a competition to make the best design, I don't see how that kind of activity, crowdsourcing activity, could be unconscious or it has to be explicit,
that's a good
right?
point. Yeah.
So.
But I don't, the competition is really not exactly crowdsourcing. I mean, competition is very, very focused. It's not public competition. It's, it's a 5 people are selected to lose money and be abused for the privilege of getting a project. And it happens over and over again in what I do. But the crowdsourcing is more as it applies to architecture, more in terms of like the democracy and architecture, because it's somehow this kind of pyramid, the architect at the very top of the mountain. That really old-fashioned idea. It usually is a male white guy, and like Fountainhead, and but now there are plenty of collaborations. The structures are quite different, and where ideas come from, really varied. So the idea, the thought.
What's an example? How do your students want to solicit input from the people about a design?
Oh, literally by asking questions, by developing programs where parametric programs where somehow the public opinion could actually transform something, so you can get the average or the high score of any thought or of any question, which I think is kind of it's not really so smart. Because you need the rigor of the discipline. You really need to know the craft and rigor of the discipline to be able to do anything. But you need to have a freshness also, and have a sense of unpredictability, and also some naivete to be able to produce something that's unexpected. So I think it's someplace along, it's a balancing act.
And I realize we're starting to get close on time. I was wondering if there's any questions from the audience. We've got one here. Can we get a microphone?
Thank you, ladies and gentlemen, for all the very stimulative discussion you had. And I'm from the neighborhood of Yokohama, outside Tokyo. And you may or may not know, but the Tokyo-Toyoko line abolished the stations of the ground level of Yokohama and onwards towards the port. And then again, the Shibuya station has gone underground. What has happened is exactly what happened in New York. We have these train lines that have been abandoned, and the concrete slabs, ugly things, just sticking into the sky with no use. And I was wondering how we could sort of learn from your experience. I think it's exactly the same situation, because people are abandoning the suburb where once the trains were running, nothing is there, nothing is happening there. And if there is the possibility of reviving the area, because people living in those areas are growing old, and then if it's getting abandoned, well, the prices of the land is going down, and people are losing hopes and complaining, but not really openly. Because if they start complaining, the land prices go down further. Mm-hmm. So I think there is the possibility of making a turnaround. And I thought, wow, your project was one, maybe a really good possibility. Or thanks very much. That was my sort of
So I guess to
question.
frame it as a question, how are these other viral ones that you saw that are copycats, how are they happening?
Usually it's governments that are, it's interesting. In the end, it boils down to money. The High Line was argued as a catalyst for development, even though no one really thought about it that much, but it was a really good formula to use that would get the politicians interested. In the end, we got far more than we expected and maybe too much. But what's nice about the High Line, in a sense, is that the one thing that we feel, besides making an imprint on New York, is we've given a kind of example to other cities. Now, before the High Line, there is the Promenade Plantée, which is in Paris, but it didn't have that kind of catalytic effect. In fact, most Parisians don't know that it exists. But I think that the popularity of the High Line can serve as an example to communities and politicians, and say, look, it happened. It's not everything can be transplanted or translated. Each city is uniquely different, has to be thought of very, very carefully. But I think it's a kind of it's at least an example of something that succeeded, and that's why they're trying it in different places without the permission of friends. It's not something that we could own, but the idea of, and it's a very sustainable idea. That's another really important argument, that why it's going to cost so much money to take down those structures that you're talking about. Well, why not rethink their purpose? And more and more, as we think forward in the city, and I remember when I used to come to Tokyo a while ago, and I couldn't recognize Tokyo because so many buildings came down and up, in very short periods. That notion of demolishing and rebuilding is pretty unsustainable, and rethinking histories. And even histories that aren't so beautiful. The High Line was always ugly. And it's nice to be ugly sometimes, It's should preserve it.
I think we have time for one last question. If there's, I see Joe.
We talk about crowdsourcing, and there's a difficult balance between total democracy and anarchy and having everybody do their own thing and having some leadership where the goals and the direction is maintained. As an example, we think about Wikipedia, and there's so many people contributing information that's verifiable or unverifiable, but there's a core group of people who keep it on direction and make sure that citations are done, or that there's something, the direction is maintained. So Joy talks about compass instead of destination. The same kind of thing. How do you keep, like in your neurology project, people or the game or thing from getting out of control and becoming something that no longer serves the purpose of the original intention? And how do you balance that sort of total anarchy with leadership and keeping a direction?
Well, in our case, as Fio said, the activity is highly constrained. So you're coloring in the branch of a neuron. It's true that it can be a problem because what we have. I haven't actually shown the game, but it's like a three-dimensional coloring book, and your task is the pages of the coloring book are images of neurons, like the ones you saw, and your task is to color one branch all the way through the cube.
So you're very tightly constraining what people can do.
Well, no, they can do it wrong. And what we do to get crowd wisdom is the simplest method of voting, right? So we have many people will try to trace the same branch through the cube, and we use voting to try to eliminate the wrong opinions.
So if you have a lot of people whose information agrees, that becomes voted up and becomes the truth.
Effectively, yeah, the points they get when they play the game are rewarding
and by the way,
agreement.
I'm going to interrupt you because this is good advertising for our workshop where we are going to have 2 hours to talk about this. So,
Good point.
So
Yeah.
Sebastian and I will be doing a workshop at 4 o'clock on crowdsourcing and brain and stuff in citizen science, which you should come to. And Fio and Neri are going to be doing a workshop probably about silk. And so with that, I'd like to thank my panelists for a really interesting conversation. And I was worried about how it was going to come together, but I think it sort of did. Thank you.
ありがとうございました。
Thank you very much. Ms. Elizabeth Diller, Sebastian Seung, and Ms. Dr. Fiorenzo Omenetto, and also Professor Ito. Thank you very much. Thank you very much indeed, all the panelists.
以上をもちまして六本木
This concludes the 10th Anniversary Global Conference Innovative City Forum Leading Edge Technology and the Future of Society session. Thank you very much indeed for coming today.